Hello everyone and welcome to another Tutorial Thursday. This Thursday we're going to do a little bit of a fun project, a do-it-yourself project, in which we are going to pick up some data from our apartment, so some temperature and pressure readings, and send them into the cloud, into an IoT platform, in this case Cumulocity's IoT platform by Software AG. And then finally we're going to pick up that data and use it in TrendMiner for analytics. So if we're going to look at our setup, it's pretty simple. We have a run-of-the-mill Raspberry Pi, very cheap and simple device, costs about $35 from Amazon. We have a little breadboard that will be used to make easy connections, so we don't have to solder too many things together. And of course, we have the sensors themselves. So if we have a look here, for example, this is a small temperature sensor, has 3 cables, very typical. 1 cable for power, 1 cable as the ground, and then the 3rd cable will typically be the actual measurement that is being sent over. Now you notice some of these sensors have indeed only 3 cables. There's one that has a few more. That is because it is sending out analog signals. For the Raspberry Pi to be able to use that signal, we have to convert it first to digital. So that's what you see over here. We have a small analog to digital connector or converter that we use to convert that signal and then send it over to the Raspberry Pi. On that Raspberry Pi, this is where the IoT platform software is running, and that will basically just pick up all the sensor data every 30 seconds, and we'll send it over into the cloud from where we can pick it up in TrendMiner for our analytics. In today's video, we'll use again TrendMiner version 2020 R1, and I will make the files available so you will have access to the same data. You can simply upload it into your TrendMiner instance so you can follow along and do the same exercises as we are doing here on the screen today. That being said, let's go. Let's see what we can make of about a month of data that I've been capturing during this lockdown period, measuring all the temperatures, pressures, and so on in our apartment. Let's see what we can do with that. Let us familiarize ourselves a little bit with the data set before we do any particular analyses. As you notice, I have about 3.5 weeks worth of data based on the date time pickers at the bottom of my screen. And I have 5 tags of interest, which are the altitude, the light sensor in our apartment, the barometric pressure, the estimated pressure at sea level, and then finally we also have the temperature inside of our apartment. As part of the first analyses, we'll have a look at the light sensor. The light is a simple proxy for the day and night cycle of our weeks, and we want to investigate whether there's any pattern in our nights and perhaps if there are any outliers. To do so, let us zoom in first on the light sensor itself. So we'll go ahead and hide the other tags, and the pink tag on my screen, as you have it here now, is the light sensor. Let me zoom into one particular day just to say a couple of things about this reading. And the first and most important thing to notice is that this is an inverse sensor. As you can see with the 2 data scooters around 10:30 p.m. to 6:30 a.m., the light reading is actually high. So high light readings means it's night, all the lights are turned off, there's no sunshine outside. And throughout the day, as we turn on lights, as the sun comes and shines on our patio and on our windows, you'll notice that the light sensor will go down. So it is an inverse sensor. And you see a very clear spike happening. So it's very sensitive to sunlight, but also to the artificial light in our apartment. What I would like to do is perform a simple value-based search, because it seems that this data is quite simple, so I can very easily look for periods where my light sensor reading is high. Those are very clearly the nights, and see if there's any pattern there. So I will go in, perform a value-based search, and obviously I will select the light tag, and as a threshold I will pick 600. 600 is right in the middle of this 200 to 1000 scale I have on my screen, which is an auto scale. And I will look for all periods where the light is higher than 600 for at least 6 hours. I don't anticipate any nights that are shorter than 6 hours, and I want to avoid any outliers or any peaks because perhaps we put something on top of the light sensor that would be interrupting here. So I'll hit search, and I find 19 results. 19 is actually a couple results less than I would have expected. The data set is about 22 to 23 days, and apparently I only have detected 19 of those events. So let's have a closer look. Instead of sorted by date, we will sort by duration to see if there are any patterns there. And you notice that most of my results are between 5 and 15 hours. Those are the buckets automatically calculated by TrendMiner. If I go into the smallest bucket, or the shortest bucket, it looks like my shortest night, April 11th, was 6 hours and 25 minutes. And the longest night within this bucket was about 9 hours 46 minutes. If I go into the other bucket, there's a couple of longer nights as well, particularly the weekend, it seems, of April 3rd and 4th. Looks like that week was particularly rough on us, and we had to restore our energy levels by having some longer nights. So there you see 2 nights that are about 13.5 to 14 hours inside of these search results. However, there is one longer outlier. An outlier that is 1 day and 9 hours long. Obviously, no night was this long, and I actually had to influence the data a little bit because the data set itself was so clean, there were no outliers. I introduced an outlier myself, basically by putting something on top of the light sensor, which then caused the light reading to be consistently high for a long period. So this is no real data, this is what I influenced, but just to introduce an outlier inside of this data set. However, you can anticipate that this behavior would also happen when your light sensor would be offline, or it would be maybe in error state, or would cause some consistently high readings. So having those outliers can be a trigger for me to actually check the health of my sensor as well. So what I'll do is I will go back into my value-based search, and instead of the 6-hour limit, let's impose a 14-hour limit. Remember, the longest night we had in this month was 13 hours and 45 minutes or so. So by putting the threshold on 14 hours, we are making sure that no normal nights would trigger this event. I will hit search, and I will only find one search result, obviously the one that I was already looking at. And I will hit save on the search. I will call this abnormal night pattern. And remember, everything I search for, I can monitor for in TrendMiner. So simply by saving the search, if I now go into my monitoring menu, I'll have an abnormal night pattern available to use as a monitor. And in this case, I simply want to set myself a notification whenever this happens. So check light sensor in this case and hit save. All right, now all I have to do is come in, turn this or toggle this monitor on. And now I don't have to look at this the sensor anymore. TrendMiner will do that for me and send me a notification whenever this happens. All right, that was example number 1, using the light sensor in our data to investigate what our normal day and night patterns look like, and then setting up a monitor whenever I expect that my light sensor is either sending false values or is broken, and I should investigate it through the monitoring result. Let's move on now to the second example. In the second example, we'll have a closer look at the temperature that we're measuring inside of our apartment and see if there's something interesting in that data set as well. Interesting to note before we dive in is that our air conditioning is linked up to a Google Nest. So through the Google Nest, we can basically set a set point for our living room whenever we're outside of the normal range or outside of that set point range. The air conditioning will automatically trigger, and it will send cold or hot air into our living room that will then obviously influence the temperature. So we will start off again with the same data set, but in this case, I will, instead of zooming into the light sensor, I will hide the tags and zoom into the temperature sensor, which is the purple tag on my screen. Now, if I zoom into a particular day of temperature readings, you very clearly see this kind of sawtooth pattern or the sawtooth behavior, which is what I just explained. So whenever we are outside of the set point range, the Google Nest will trigger air conditioning, and this will then trigger a quite intense period, about 15 to 20 minutes, for example, here, where cold air is being blown into the living room to get the temperature back down. Then, of course, the air conditioning will shut off again, after which slowly but surely the temperature will rise up again. This is of course because direct sunlight is hitting our patio, it's hitting our windows, it's heating up the inside of the apartment again. And then whenever the next set point threshold is triggered, we will again trigger the air conditioning to get the temperature down. Now, if you look in this data set, there are a few short periods, short bursts, as I mentioned, about 20 minutes, but there's also a couple of larger periods where, in this case, for example, we have about an hour and a half of air conditioning being active. Now, our assumption is that these longer periods actually cost more energy, so our electricity bill would go up. So I want to quickly investigate whether this is something that happens more often, perhaps this was just an outlier, or if this is something that my partner and I should be aware of when we are inside of the apartment. For example, making sure that we close the doors, that we don't change the set point too abruptly, perhaps that we try to be more at a constant value rather than letting the temperature go up and down like that, to reduce on our energy consumption. In this day and age, of course, we want to be as eco-friendly as possible. So this is a very specific pattern, which is a perfect fit for TrendMiner similarity search. So that's what I'm going to do now. I'm going to go back into my search menu and I will trigger a similarity search. In this case, I'm not really interested in the specific absolute values, right? This could be triggered from any kind of starting point. So I will select signal shape instead. And to retain only the best results, I will set the minimum score to 80%. To remove perhaps other periods where the temperature was a little bit unstable, but was not as clearly going down as in this case. When I hit search, I find 16 different or individual search results of 16 periods where this happened. So let's have a look at a couple of them. I will overlay them on top of my screen. And what you notice is indeed, as I select these first 6 results, for example, is that there is indeed, starting from whatever baseline we were at, so between 23 and 24.5 degrees Celsius, that's when the set point change was triggered. And then it takes over an hour, almost an hour and a half, to get to the final baseline or the final result that I was interested in. So this is the type of behavior I want to be monitoring for. I want to check when this is happening. So in this case, I will use the fingerprinting capabilities of TrendMiner to build a fingerprint. As you can see, by selecting Add Fingerprint, I nicely capture this dynamic behavior of my temperature. And I will call this large temperature change, which corresponds to at least about a 3 degrees Celsius change. So 3 degrees Celsius or about 5.5 degrees F, or degrees Fahrenheit, was triggered in this case. I will save this fingerprint. And again, as you can search for things, you can monitor for them. I can also monitor for fingerprints. So the dynamic behavior I just saved can also be used for monitoring purposes. So I will go into my monitoring menu and I will select this large temperature change that I had just saved. And in this case, I'm interested in deviations, right? So you can imagine when I'm having the air conditioning going full blast, but I leave all the windows and the doors open, that will cause even longer delays in reaching the temperature we're after, and will cause more energy to be consumed and wasted, basically. So I'm interested in deviations from the behavior I just stored. And there is one step I would normally have to take that I'm skipping for today, is I also have to set up a trigger, because deviations always work with a trigger. In this case, set point change of the temperature is when I want to have TrendMiner monitor for these deviations. So that would be one step for you as a home study to set up this search yourself. In this case, I've selected it, and again, I will set up a notification to be sent to myself. And I will hit save on this fingerprint detection. Anytime this behavior is now detected by TrendMiner, or a deviation of the behavior, I will get an email message. And the nice thing about it is that this email will also contain a link that directly takes me back into TrendMiner, so I can immediately start investigating what in particular happened that moment in time when this deviation was triggered. All I have to do now, again without any programming, is turn this fingerprint monitor on. From now on, TrendMiner will be doing the heavy lifting in the background. Will be watching this for me. It's like having a wingman on my shoulder that's looking out for me, and I don't have to watch the screen or this visual the whole time myself to be detecting these behaviors. All right, that concludes our second example, in which we used the temperature sensor inside of our apartment, and we set up a monitor for those large temperature changes that, first of all, I would like to avoid, but second of all, I want to see if perhaps there are any outliers, any deviations from this behavior, because those could be linked to energy waste because my windows or my doors are all open. And I want to avoid those because I don't want to have a large electricity bill at the end of the month. For a third and final example with this data set, we'll have a look at the barometric pressure. The barometric pressure has a large influence on the local weather. So I want to see if, with the sensor I have available here in my little setup, if I can use those sensors to predict what the barometric pressure would do, assuming that, for example, my pressure sensor would go bad or would be offline for an extended period of time. Because it's such an important indicator of the weather, I want to predict it even if the sensor is not available. So for the third and final time, I will start from the same data set, but in this case, I will hide all the other tags and zoom into this brownish green tag, which is my pressure reading. As you notice, typically for the longest part of this data set, we are within the normal range for barometric pressure, but there are actually a couple of outliers, so it could be interesting as a next step to pull in some weather data and see whether there was actually, for those low extended periods, there was some impact on the weather. But in this case, I just want to build a model, and I want to use the available sensors to see to what extent the barometric pressure can be predicted. Building models in TrendMiner typically will be done through the influence factors capability. And the first thing I have to do is select the tag of interest. Of course, my tag of interest in this case is the pressure. So the barometric pressure, this is the one that I'm trying to predict. And I'm not going to hit global search in this case because I just want to single out the tags that I was already looking at. So those 5 other IoT tags that I'm interested in. To build the model, the first thing I have to do is hit analyze, which triggers TrendMiner to look at all the tags and see to what extent it can be used to predict my pressure tag in this case. You notice that 2 tags pop up with 100% confidence, and that's because actually the altitude and the sea level pressure both come from the same sensor on my Raspberry Pi. So of course those 2 are correlated also between themselves. And in this case I want to start off with the altitude. I will hit the plus icon to add it to my model. And you notice that automatically TrendMiner will now recalculate also the additional influence from the other tags. And you notice that the sea level pressure actually dropped to 0. And that's very important because you don't want to add tags that are correlated between themselves into my model because they don't really add any additional value to my model. You've also noticed when I added this candidate that a dotted line appeared on top of my original green tag. It's very hard to see, so what I can do is actually save the output of this model now. So I'm going to save this as Tutorial Thursday IoT pressure prediction. TrendMiner automatically sets the formula and all the inputs correctly for myself, so I don't have to take those steps manually. And when I hit save, this tag will now also be populated on my screen. And let me change the color here from yellow to red so you can very clearly see it. And you notice indeed that the red tag really predicts very nicely the behavior of my pressure tag. So even if the pressure tag would now go offline, I can have very good confidence that the pressure prediction tag that uses the altitude as input will be very useful to continue my weather predictions, for example. Of course, as in any model, it is not perfect. So there's a couple of periods where perhaps the model predicts a little bit different than the actual output. And I can now go back into the influence factors menu to see if any additional tags could be used to help me predict those outliers as well. There we have it. That was our third and final short example where we use the influence factor capability to predict what the pressure is doing, setting ourselves up, for example, for the case when the pressure reading itself would be offline or would throw an error. We can still rely on the other sensors to make prediction with good confidence about this barometric pressure. All right, there we have it. That was it for today's Tutorial Thursday. It was a nice little side project for me, working with a little bit of hardware, setting up some sensors, sending this over, streaming this data live to an IoT platform that can then be used to analyze in TrendMiner. It delivered us a nice, fun data set to play around with. As mentioned in the beginning, we will link to these data sets in the description so you can manually import them into your own TrendMiner environment. But if you think about it, this is basically how nowadays you could very easily set up your own data gathering solutions. So you don't have to invest a lot, just a couple of sensors, stream that data live to an IoT platform, and from there you can pick that data up for analysis. So Particular use cases could include some kind of sensor that you're not sure about whether you should actually hardwire it or not. You can do a couple of tests. It's very easy to get going, and then once you've been able to analyze the data set, you can make a final decision. So even though this is a simple home-based solution, there are applications out there in the industry that could be useful to you as well. So I hope you learned something. I hope you had some fun as well, and see you next time.